So in futures, we could pass runnable and callable types of tasks only. In completable futures, by contrast, we have the supplier first, which denotes a functional interface that can be used to supply values. Usually, we use the supplier at the beginning of a pipeline to supply values we want to work with in later stages of the pipeline. After supplier, we have a function, which is again a functional interface. This is used as an intermediate phase in many pipelines to transform values, to take in an input and provide an output. We also have the consumer, which is a functional interface which takes in values but doesn't return anything. It's sort of the opposite of a supplier, and from the name itself, it is obvious that it is there to consume and not to return anything back. And of course, we have the runnable that we have also seen in futures. So now, depending on the tasks at hand, we have to chain these pipeline tasks one after another, and of course use the executor service to allocate these tasks so that we get the desired outcome much faster. So now, as I mentioned, the supplier, function, consumer, and runnable are functional interfaces. So if they are functional interfaces, they have one abstract method, and this one abstract method is what we try to implement using a lambda. And once we implement this lambda, we provide this lambda to the corresponding completable future function so that it can be executed. Now these completable future functions are higher order functions because they accept lambdas as arguments. Now don't worry if you didn't get that completely. We'll do some repetition in the slide. So first we have the supplier, which is a functional interface. The supplier, as the name suggests, supplies values. It has one abstract method, which is get. When we want to use the supplier in our pipeline to supply some values, we implement a lambda describing what we really want supplied. And then we pass this lambda to the supply async completable future method to get it scheduled and executed and all that good stuff. So supply async is the higher order function here. Then we have the function, which again is a functional interface, which again does what its name suggests. It takes an input and transforms it into output because that is what functions do. The abstract method here is apply. When we want a function to take in some input values and provide an output, we override the apply method of the functional interface to transform the input into the desired output, and then we pass this lambda to the then apply completable future method to get it scheduled and executed. Again, then apply in this case is the higher order function which accepts the lambda. And finally, we have the consumer functional interface, which again, believe it or not, does what its name suggests. It consumes or accepts values from previous stages of the pipeline. The one abstract method for consumer is accept. The consumer, as I've mentioned earlier, is the final stage in many pipelines as it does not return any values. Once again, we implement the accept method by using a lambda describing what we want to do with the input value, and in this case we pass this lambda to the then accept completable future method to get it scheduled and executed. So again, then accept is the higher order function in this case. And then of course we have the runnable, which we've always had, which is used when there is nothing to be passed or returned. Now, even though the names pretty much do what they say, I came up with a stupid acronym so that I could remember it. Maybe it would be useful for you guys to remember as well. So you can remember far and car with an S in between. So FAR stands for function accepts and returns. So whenever you need to both accept and return values in the pipeline, use a function. Now CA at the bottom stands for consumer accepts. So whenever you are at the final stage of a pipeline and want to do something with the final value, you use a consumer which just accepts, doesn't return. And then obviously we have the runnable which doesn't accept or return any values. And we also have the supplier that only supplies values but does not accept any values. And yes, it is actually important to remember these and come back to this, since this is the basis of what we are going to do in the future. It forms the building blocks of completable futures. Okay, so enough of the theory. You guys must be itching to code this out. So what I'm going to do in the coming lectures is build out the order inventory example that we saw previously. Only this time I will use completable futures instead of futures, so that we know the advantages of using completable futures. For the supplier, I will code out both the lambda as well as the equivalent anonymous inner class overriding the get method, just so that we get to see the equivalence between the two methods. For the other two functional interfaces, namely the function and the consumer, I will write out the lambdas but provide you resources and assignments for anonymous inner class implementations. And of course, we will be passing these lambdas to the respective completable future methods to execute and get the job done. So let's get started. Please remember to code alongside me in the next few lectures. I'll see you there.
Now, lastly, as always, if there are any questions about the content, please do let me know in the comments below. Also, if you would like me to cover any more programming topics, please also let me know in the comments below. And finally, since this is a new channel, if you like the video, please like, share and subscribe, and please click on the bell icon to be notified about future video uploads.